Teaching Demonstration M102. Hi everyone, my name is Trestan Cahigao from Bachelor of Secondary Education, major in Mathematics. So let me discuss the objective first. Objective. At the end of the lesson, students are expected to first define the relationship and identities of each expression. Second is simplify the expression. And lastly, students are expected to evaluate the expression. So let's start. Let me ask, who wants to lead us a prayer? Okay, Nunoy, please lead us a prayer. Thank you, Nunoy. Okay, good evening, class. Please be quiet. Okay, let me check your attendance first. Trisha, Nunoy, Maningning, Tuting, Puput, Cassandra, Tirisita, Jennifer, Merv, Gani, and lastly, Card. Wow, it's good to hear that all of you are present, so let's start our class. So this is our topic tonight, the simplification of trigonometric expression. Identities enable us to simplify complicated expressions. They are the basic tools of trigonometry used in solving trigonometric equations. Just as factoring, finding common denominators, and use special formulas are basic tools of solving algebraic equations. In fact, we use algebraic techniques constantly to simplify trigonometric expression, basic properties, and formulas of algebra, such as difference of squares formulas and the perfect square formula, and simplify the work involved the trigonometric expression and equations. So let me define the relationship and identities of each expression. As you can see in the picture, there are four identities or relationship of trigonometric expression. First is reciprocal identities. Second is quotient identities. Third is Pythagorean identities, and lastly is cofunction identities. So first, let me discuss the reciprocal identities. Reciprocal identities are the reciprocals of the three standard trigonometric functions named sine, cosine, and tangent. In trigonometry, reciprocal identities are sometimes called inverse identities. And also, reciprocal identities are inverse sine, cosine, and tangent function written as arc. Prefixes such as arcsine, arccosine, and arctan. For intent, functions like sine over negative 1x and cosine over negative 1x are inverse identities. Either notation is correct or acceptable. As you can see in the picture, there are some examples of simplifying reciprocal identities. First is sin theta equals 1 over cosecant theta, and cosecant theta equals 1 over sin theta, and cosine theta equals 1 over secant theta. Secant theta equals 1 over cosine theta, and tangent theta equals 1 over cotangent theta. Cotangent theta equals 1 over tangent theta. And that's all how to simplify reciprocal identities. And next, quotient identities. Quotient identities. In trigonometry, quotient identities refers to trig identities that are divided by each other. There are two quotient identities that are crucial for solving problems dealing with trigs, those being for tangent and cotangent. Cotangent, if you're unfamiliar with it, is the inverse or reciprocal identity of tangent. Its identity will be more clear in the next section below. This image covers the two fundamental identities you must know when it comes to quotient identities. Okay, let me give the example of quotient identities. First is tangent theta equals sin theta over cosine theta. Next, cotangent theta equals cosine theta over sin theta. So let's proceed in Pythagorean identities. The Pythagorean trigonometric identity is also called simplified Pythagorean identity. Is an identity expressing the Pythagorean theorem in terms of trigonometric functions along with the sum of angles formulate. It is the one of the basic relation between the sine and cosine function. So let's start with the example of Pythagorean identities. Sin squared theta plus cosine squared theta equals 1. And sin squared theta equals 1 minus cosine squared theta. And next cosine squared theta equals 1 minus sin squared theta. 1 plus tangent squared theta equals secant squared theta. Next is secant squared theta minus 1 equals tangent squared theta. 1 equals secant squared theta minus tangent squared theta. 1 plus cotangent squared theta equals cosecant squared theta. Next is cosecant squared theta minus 1 equals cotangent squared theta. And lastly is 1 equals cosecant squared theta minus cotangent squared theta. And lastly, the cofunction identities. The cofunction identities shows the relationship between sine, cosine, tangent, cotangent, secant, and cosecant. The value of trigonometric function of an angle equals the value of cofunction of the complement. Recall from geometry that the complement is defined as two angles whose sum in 90 degrees. So let me discuss the example of cofunction identity. First is sin pi over 2 minus theta equals cosine theta. Tangent pi over 2 minus theta equals cotangent theta. Secant pi over 2 minus theta equals cosecant theta. Cosine pi over 2 minus theta equals sin theta. Cotangent pi over 2 minus theta is equal to tangent theta. Cosecant theta pi over 2 minus theta is equal to secant theta. Okay, I hope you learned about the identities of trigonometric expressions. So let's proceed in simplifying expression. As you can see in the screen, there are the simplifying trigonometric expression. The identities can use to simplify trigonometric expression. Okay, let's simplify. Let's start with the basic. Letter A. Cosine theta plus sin theta tangent theta. So let's solve. Cosine theta plus cosine theta sin theta over cosine theta equals cosine theta plus cosine squared theta over cosine theta equals cosine squared theta plus sin squared theta over cosine theta equals 1 over cosine theta. So let me ask, what is the answer in letter A? Very good. It's secant theta. Let's proceed in letter B. Here is the problem. Cotangent squared theta over 1 minus sin squared theta. So let's solve. Cosine squared theta over sin squared theta over cosine squared theta over 1. And cosine squared theta over sin squared theta times 1 over cosine squared theta equals 1 over sin squared theta. So let me ask in the class, what is the answer in letter B? Okay, it's correct. The answer in letter B is cosecant squared theta. And here's some example of simplifying trigonometric expression. Identities can be used to simplify trigonometric expression. This is to simplify a single trigonometric expression. Simple letter A, sin theta and cotangent theta. 2. Sin theta cosine theta over sin theta. So let me ask again, what is the answer in letter A? Very good. It's cosine theta. Let's proceed in letter B. So here is the question. Cotangent squared theta over 1 minus sin squared theta over cosine squared theta. And it's equal to cosine squared theta over sin squared theta times 1 over cosine squared theta equals 1 over sin squared theta. So let me ask, what is the answer in letter B? Very good. The answer in letter B is cosecant squared theta. As I can see, all of you are understand my instruction and discussion. So let we have a group activity. Let's make group of 3 containing 3 members. I will give 1 minute to make your group. Okay, it's 1 minute done. I hope all of you have a group. So let's start our group activity. Okay, are you ready? Group 1. Please verify and simplify this problem. I gave you 2 minutes to answer. Okay, group 1, time's up. Okay, what is your answer, group 1? Very good. Your solution and answer is correct. The answer in number 1. The answer number 1 is sin squared theta. We have the same solution. Here is the solution. Secant squared theta minus 1 times cosine squared theta equals tangent squared theta times cosine squared theta is the Pythagorean identity and equals sin squared theta over cosine squared theta times cosine squared theta is the quotient identity. And here is the answer. Sin squared theta is multiply and divided out common factors. So very good, group 1. I will giving you 10 points for that, equivalent of 100% points. And next, group 2. Please answer number 2. Okay, group 2. The same in group 1. Please verify and simplify this problem. Number 2. Secant squared theta over 1 minus cosine squared theta equal tangent squared theta. I am giving 2 minutes group 2 to answer this problem. Okay, time's up. Group 2, please give your answer. Group 2, it's correct. The answer in number 2 is tangent squared theta. Here's the solution. Secant squared theta 1 minus cosine theta equal to secant squared theta minus secant squared theta and cosine squared theta. This property is distributive property. And proceed. Equals sec squared theta minus 1 over cosine squared theta. Cosine squared theta is reciprocal identity. And proceed. And let's proceed. Equals secant squared theta minus 1. And the answer is tangent squared theta. And its Pythagorean identity. So group 2 got the correct answer. So I gave 10 points for that. It's overall 100%. So let's start with the last group, group 3. Please answer this problem, number 3. So, group 3, please answer this problem, number 3. Sin theta minus sin theta cosine squared theta equals sin cube theta. Group 3, I am giving 2 minutes to answer this problem. Okay, time's up. Okay, group 3, give me your answer. Very good, group 3. The answer in number 3 is sin cubed theta. It's already in the problem. And here is the solution. Minus sin theta cosine squared theta is equal to sin theta 1 minus cosine squared theta. Its factor. Let's proceed. Sin theta sin squared theta is a Pythagorean identity. And the answer is sin cubed theta. Multiply. All of you got the correct answer, so I gave you 10 points. And that's 100% overall in your performance. As I end this discussion, please copy the assignment on the screen. 9 items, each 10 points each. And pass it on our GCR. Thank you and God bless. By the way, who wants to lead the closing prayer? Okay, Trisha, please lead the closing prayer. Thank you, Trish. Okay, goodbye, class.